So let's look at the load, link, store, conditional instructions, which usually we call LL and SC instruction. We have them because atomic reading and writing in the same instruction, even if we just do the write, if the read has tested positive for something, is really bad for pipelining our processor. Let's look at the classical 5-stage pipeline where we fetch, decode, and read registers, do the ALU operation. This is where we compute the address for memory instructions. Then we have a memory access stage. And finally, we write the result to a register if a register result exists in the instruction. Loads would be fetched, decoded, and read the register, compute the address using that register, access memory to get the value from that address, and then write the result to a register. An atomic read-write instruction, such as a swap, or test and set, or test and write, would compute the address and read registers, and then when it gets to the memory stage, it cannot do everything it needs to do in one access to memory, because loads and stores do either a read or a write. A read-write instruction needs to do both, and that cannot be done in the same cycle for the same memory location without really complicating the memory stage a lot. So just for the sake of atomic read-write instructions, we would need to add memory 2 stage, possibly memory 3, so that they can read the memory, do some checking, and then finally write the memory. So we would be adding to our pipeline several stages possibly just for these instructions, but remember that every instruction flows through the pipeline the same way. So if we add these 2 stages, for these instructions, we really have added 2 stages for all instructions, which is not very good, because these are actually not going to execute that frequently to justify this. So we will separate the atomic read and write into 2 instructions. The first will be a load-linked instruction. Its purpose is to implement the read part of the atomic operation. What it does is it behaves just like a normal load. It just reads from a memory location and puts the value in a register. But in addition to that, it saves the address from which it loaded into a special link register. So that's the only thing that it does that is different from a normal load. The store instruction that we will use to implement the write part of the atomic read-write operation is called a store conditional. What it does is to check first if the address that it computes is the same as the one in the link register. If the address is the same, then it does a normal store to that memory location and returns a 1 in its register. If the address that the store computes is not the same as the one in the link register, then it just returns 0 in the register without storing anything. These 2 are behaving like a single atomic operation because of the link register. So let's see in more detail how that works.